I'm Gerrit Loubser, and this is my Airfoil Selector, my final project for CS50. It's a Python program which assists in selecting airfoils for low-speed purposes. It selects airfoils based on tested performance obtained from the University of Illinois at Urban-Champaign low-speed airfoil tests. These are a database of wind tunnel tests for many airfoils at low speeds and low Reynolds numbers. More on Reynolds number later. The data is available in text file format from the website indicated, and access is free for any use, but the data is copyrighted, so use needs to be properly credited. Systems typically operating at low Reynolds numbers include birds, small wind turbines, micro air vehicles, unmanned air vehicles, and human-powered aircraft in addition to model aircraft. The Reynolds number is a dimensionless coefficient that measures the ratio between inertial and viscous effects in a flow field. Low Reynolds number flow is characterized by a boundary layer that transitions from laminar to turbulent, which often leads to flow separation and the formation of separation bubbles as visualized in the images on the right, courtesy of the UIUC as well. The results are higher drag than expected and a lift curve that's non-linear. These complexities make referring to physical test results especially important when working in this realm. My program consists of, firstly, an airfoil loader utility, which is to be run only once. It reads the performance data from text files downloaded from the UIUC and handles the different data formats that exist between earlier and later tests, and then saves all data in a uniform format into a JSON file. The second program is the actual selector. It obtains selection criteria from the user, including a Reynolds number range, the maximum number of airfoils to isolate, and the figure of merit to use. This can be lift coefficient, drag coefficient, or lift to drag ratio. The program reads the airfoil test data from the JSON file, extracts all data within the desired Reynolds range, and then ranks extracted airfoils appropriately using the desired figure of merit. The appropriate number of best performing airfoil datasets is then selected, displayed and saved, and also graphed and saved. The output looks like this in text form and like this in graphical format, but let's rather have a look at the program itself, which I've run up here. Defining the band of Reynolds numbers, I'll accept the default there, make the maximum say 80,000, accept the default there, and then we'll pick 7 airfoils to isolate, and we'll use the lift to drag ratio. There the text data, and there's the graph data. Thank you very much.